Hello everyone, I hope you're doing well. So in this video, we're going to discuss the Geeks for Geeks problem of the day, and today's problem is minimum days and it is of medium level. So let us quickly start with the problem. This particular problem says that we have been given a string S and we have been given an array or a vector P. Now what we essentially have to do is, for example, this is the string and this is the vector. We have to traverse through each of those elements in the vector. For example, first we have to start from 2, then 1, 3 and 0 like this. So when we are at the first position, the element is 2. So we have to go to the second index of the string starting from 0. So at 0 A is there, then at 1 this A is here, and at 2 this B is here. So essentially what we have to do is we have to replace this particular B with a question mark. Let me just explain you it more clearly. So for example, 4 is the length of the string and the elements are A, B, B. So this is at position 0, 1, 2 and 3. Now the vector that has been given to us is 2, 1, 3, 0, right? 2, 1, 2, 1, 3 and 0. So in the first step, what I'll do is I'll go to the second position and I'll replace it with a question mark. So this should be like this. After the second step, what I can do is I can replace that particular index with a question mark. So in the second step, the string will be like this. So I have to find like the minimum number of operations I need to do starting from the left. So this is counted as one operation when you mark the element at index 2 as question mark, and you mark the element at index 1 as question mark. So each of those is one operation, right? So here we have till now done 2 operations. If I decide to like take this particular 3 also, then it will be like this, the string will be like this, right? And this will be counted as 3 operations. So we have to tell the minimum number of operations required such that no two adjacent elements are equal. So for example, these two elements are adjacent and they are equal. These two elements are adjacent and they are equal. So we have to find the minimum number of steps or operations required such that no two adjacent elements are equal. Now let us just check the second test case also. So it is ABCA. So if you observe, then here no two adjacent elements are equal, hence the answer will be 0. No matter what the array given input array is, the answer will always be 0 because there are no two adjacent elements that are identical or same, right? So a very important observation to this question is, so the first important observation is that whenever you take an index, for example, if some element x is present here, right, whenever I take it and change it or updated it to a question mark, so what will essentially happen is it can affect at maximum 2 positions. So the first position that it can affect is this one, the one right after it, and the second position that it can affect is the one to the left of it, right? These are the only 2 positions that this particular element can affect. So we have to observe how this particular element can affect those 2 positions. Now let us talk about the right position first. So if the particular element x at this position is equal to this particular element y to the right of it, right? So if for example these are 2 variables names that I am taking, for example these are a and a, right, or they are b and b, or they are c and c, they are anything similar, what will happen is when I replace this particular element with a question mark, now these 2 elements will not be equal, right? So this results like in changing an identical set to a non-identical set, right? Similarly, when I do for a left thing, if some element y is present to the left of x, when I update this particular element to a question mark, now if they were similar earlier like this, they will not be similar anymore, right? Because this would be updated with a question mark. So what I can do is I can initially keep track of all the elements that or all the positions that were similar. So for example, in this particular example, the first one, A, B and B, I can keep track of all the positions that are similar to the right of it, to the element right of it. So for example, A is similar to this particular A. So the element at position 0 is identical to the element at position 1. So I can save 0 in my array or in any data set I want, right? Similarly, this particular B is similar to this particular B. So what I will store is I will store 2 in that data structure, right? So I will have the list of all the indexes that are identical to the element of right of it, to the right of it. right? So in this case 0, 1, 2 and 3. So in this case 0 and 2 are the indexes in which that particular element is equal to the element to the right of it. So now the next question is how this particular thing will help us. Now whenever you find an index in the array, given input array, for example here it is given 2, right? What I'll do is I'll go to 2, I'll update it with a question mark, but before that I'll check whether this particular element is equal to the element to the right of it, right? So if this is equal, then I can easily remove this particular element from this list. So for example, b and b are equal, I can remove 2 from this list, right? Again I will check to the for the left thing also whether this particular element is equal to the left of it or not. Now in this case it is not equal, so I don't need to do anything, right? Now for coming to 0, now the next element is 1. So for example here it is 1. I'll check whether this particular element is equal to the element to the right of it. So a and b are not equal. Now I'll check for the left element. Now these two elements are equal. So what I need to do, I need to remove this particular 0 from my data structure, and this will be also be removed, right? So at the end, whenever all my operations are completed such that there are no two identical elements adjacent, the size of this data structure will be 0. So this particular thing can be used as an indication that our operations have been completed and no more further operations are required. Now the next question is, which data structure should we use? For this question I used a set. So I used set just because like it is easier to insert elements and remove elements as well. And even if you remove the same element multiple times, it will have no effect. So for example, if you had 0 in the set earlier, now you removed it and you remove 0 again, so there will be no such problem. So initially what I'll do is I'll insert all those positions of in which the right element is equivalent, and I'll just traverse through the given input array. I'll start removing, I'll go to all the positions starting from the 0th index in this particular array and check once for the right and check once for the left, and I'll remove the respective positions from my set, right? And as soon as my set, the size of my set becomes 0, I know that I need no more operations and all the identical adjacent elements have been already removed. So let me just show you the code now. So what I have done is I have taken a set of integers to remove. So these will be the indexes that I need to remove in order to make sure that no two adjacent elements are equal, right? So I just traverse through all those positions from 0 to less than n minus 1, and for all those positions where s of I is equals to s of I plus 1, I just insert it into the set, right? So now I initialize my answer with 0 and I just traverse through all the values in the given input vector. And as soon as I first check this particular condition whether the elements that I want to remove is 0 or not, right? The size of my set is 0 or not. If it is 0, I just break out of my for loop. Otherwise I increment my answer, and now I check once for the right. So I can only check for right when I is less than n minus 1, right? And s of I is equals to s of I plus 1. They should, both of the elements should be equal, right? So what in that case, what I do is I just remove that particular element from the set or that particular index from the set, right? Now to check for the left element, I should be at least greater than 0, and both of those elements, the element at the ith position as well as the element at the I minus 1th position, should be equal. Now if these two elements are equal, I just remove it from the set, and this loop continues, and at the end I just return my answer. So this was the solution for today's problem of the day, minimum days. I hope you guys were able to understand the solution. So till the next video drops, keep coding, stay safe, bye bye.